Hello, ladies and gentlemen. Welcome to JB Jumbo Online Mathematics. Today, we will not learn mathematics. We are not looking at mathematics today. We are going to focus our mind on physics. You can see what we have on the board: motion. Motion is the first topic we are dealing with in physics at this time. Okay, you can see from what we have there, definition of motion is very clear on the board. Definition of motion, very, very clear. See, we say motion is described as the change of position of an object with respect to time. Example of motion, can see the electron revolving around the nucleus, and water flowing from the tap, the movement of smoke in air, the motion of wheels of moving vehicle, and also motion of earth on its axis, etc. We still have so many example of motion. Now, a body or an object that possesses motion are said to be in motion. We still have other example. Now, we also said again that motion is really described in terms of all these I have given you. Look at it. It's described in terms of distance, speed, velocity, speed. Okay, we are having speed again here. Please just track one. Just track one. I repeated this one. Meaning that motion is described in terms of all these. Okay, let me take this one as velocity. Let me take this one as acceleration. Let me take this one as acceleration. That is number 4. It was speed before. Let me change it. I repeated it twice. This one will be acceleration. Acceleration. Mean that we can also describe motion in terms of distance, speed, velocity, acceleration, displacement, and time. You can see this is all about the concept of motion. Now we are going to look at the next thing there from what we are given at the bottom. Remember I told you that motion is described in terms of this, meaning we are going to analyze all this one now, and I will give you the definition of all this, and I will also tell you the dimension, the formula. I will give you the formula, and I will also give you the dimension. Okay, I think we can continue now. Please, I hope you are okay with that. Let me just give you a second so that I go through the work we have on the board. After we should look at the distance, speed, velocity, acceleration, displacement, and time. Okay, now let us now look at distance, speed, displacement, velocity, and acceleration. Then look at distance, speed, displacement, velocity, and acceleration. Now, what is distance? Distance simply means the length covered, or the extent reached by a body or an object. The distance covered or the length covered can be defined in terms of length covered or the extent reached by a body or an object. Now, this distance we measure it in meter. The distance is measured in meter. Mean that we use meter to measure distance. We use meter to measure distance. It is measured in meter. We use meter to measure distance. Meter. Okay? We use meter to measure distance. And the other one there, okay, don't also forget that distance is a scalar quantity. Distance is a scalar quantity. Now, what is the dimension for distance? What is the dimension for distance? Dimension for distance. Dimension for distance. Dimension for distance is L. The dimension for distance is L. While the unit is meter, while the dimension is L. And don't forget, I said distance is a scalar quantity. Now, while the other one speed, we have the other one is speed. Now, what is speed? Speed is simply the time rate of change of distance. Speed is simply defined as the time rate of change of what? Distance. The time rate of change of distance. It means that this speed is defined as distance traveled. Distance traveled. Speed is defined as distance traveled over the time taken. Over the time taken. The time taken. Speed can be defined as the time rate of distance traveled. Now, speed is a scalar quantity. Speed is also a scalar quantity. We said distance is a scalar, speed is also a scalar quantity. Now, how do we measure speed? Meaning we measure it. Remember, I told you that distance is measured in meter. Now, how do we also measure speed? Meaning, what is the unit for measuring speed? Remember, the unit for measuring from the formula, the unit for measuring distance is meter, while the unit for measuring time is seconds. Therefore, we can say this one can also be written as 1 times 1 over x. When we apply the law of indices to this place, law of indices, therefore taking the reciprocal of this one, we have what m, which is the ms. Can see that the s is carrying 1. Therefore, we can say the unit for measuring distance is meter per second. Meter per second, either it is measured in this or we use this very one to measure it. Any of the one we use is very much accepted. It means that we use this one to measure speed. And now, what is the dimension for speed? What is the dimension for speed? You can also get the dimension for speed from the formula we have on the board. You can also get the dimension for speed. What is the dimension for, in terms of the formula, what is the dimension for distance is L. And what is the dimension for time? We still use what? Time. Therefore, now I can say, remember I told you that this one can also be written as 1 over t. Now taking the reciprocal, become 1, that 1 become what? T power minus 1. Therefore, this one become the dimension. This one here become the dimension for speed. That is the LT power minus 1. This is the dimension for speed. And don't forget, I repeat again, the speed is a scalar quantity. It is a scalar quantity and it is measured in meter per second. Now that one there is for the speed. Let us now look at the one of acceleration in the board. Let me show you this side of the board and let us look at acceleration. Now what is okay? The next one is displacement. And what is displacement? You know what is displacement? The next one there is displacement. The next one is what? Displacement. Now, what do we mean by displacement? What do we mean by displacement? We basically mean that displacement is the distance traveled in a specified direction. The distance traveled, displacement means the distance traveled in a specified direction or in a given direction. The distance traveled in a given direction or in a specified direction. And this displacement is a vector quantity. It is not scalar, it's a vector quantity. And remember we said displacement is distance. Meaning therefore we can also measure it in terms of meter. Meaning it can also relate to distance and it's also measured in meter. Meaning displacement is measured in meter. But now you should know the difference between displacement and distance. Distance is scalar, while displacement is a vector. Okay, that is a vector quantity. While this one is what? A scalar quantity. Now, what is the dimension? The dimension can also be L. The dimension can also be L, that is for the displacement. Let's now look at the other one, which is velocity. What is the velocity? Okay, let's look at the velocity. And what is velocity there? What is velocity there? Velocity simply means what? The time rate of change of displacement. The time rate of change of displacement with time. It means that we can define velocity as what? The change of displacement. Displacement, we can use S as displacement, or we can also use D. Sometimes in some textbook they use what? D to represent what? Displacement. Because we said displacement is the distance traveled. I can as well use D to represent it. I can also say D over T. It means that is the time rate of change of what? Displacement with time. Now, what is for velocity? Velocity is also a vector quantity. It is not scalar, it is a vector quantity. Now, we measure velocity. We measure it in terms of the formula. Now, what is the formula? Let's look at the unit for measuring velocity. The unit for measuring velocity, meaning what is the unit for distance is meter, and the unit for time is second. It means that we can also measure it. It means that velocity has the same unit as the speed. It means that we use the same units. The one we use for speed is the same unit we use in measuring velocity. Meaning that you say velocity and speed has the same what? Unit. I can also say it is measured in meter per second. This is how to measure it. Now, what is dimension? It means that velocity also has the same dimension with speed. But you should know the difference between speed and velocity. Speed is scalar, while vector is velocity is vector, speed is scalar, velocity is what? Vector. Now the dimension, remember I told you that they have both of them have the same dimension. Therefore, we can also see for velocity, the dimension is what L, which is LT per power minus 1. That is the dimension there. Now let us see the last one, which is the acceleration. Now what is the last one there? Acceleration. And what is the acceleration? Acceleration is the time rate of change of velocity with time. Acceleration is the acceleration. Okay, let me just say A. A stands for acceleration. Okay, let me put it this way. Acceleration, it means that is the time rate of change of velocity. Velocity, let me put it this way, with time, t. With time, we can also define it in this way, the time rate of change of velocity with time. Don't forget that acceleration is not a scalar. It is not a scalar. Acceleration is not a scalar, it is a vector quantity. Acceleration is what? A vector quantity. Now, what is the dimension for acceleration? What is the dimension for acceleration? What is the dimension? Okay. Now, what is the unit? Before we look at dimension, what is the unit for acceleration? Now, to determine the unit for acceleration, simply use this one. Let me get a good marker. Now, we simply use this very one in terms of the formula for acceleration. The unit for measuring velocity is okay. Acceleration, we use this one. This one is measured in meter per second. While remember we have t also under. Therefore, now when we do it mathematically, we are going to have meter over l square. It means that I can as well write in terms of acceleration, I can measure it in this form, or I will measure it in this form. It means that it comes what meter per second square. Meter per what? Second square. This is the unit used for measuring acceleration. Now, what is now the dimension for acceleration? What is now the dimension for acceleration? To determine the dimension for acceleration, the dimension of for acceleration. Let us look at dimension for acceleration. Let us see dimension for acceleration. Now, what is going to be the dimension for acceleration? Meaning now for the formula, remember I gave you the formula is this. Acceleration is defined as the time rate of change of velocity with time. Remember I told you that one before. You mean that what is the dimension for velocity? Dimension for velocity is LT, don't forget, is what? LT power minus 1. Remember we have time under, this one will be what? Over T. Now this very one, I can as well write, this one can as well be written as what? LT power minus 1 times this T under, it becomes which is the times T power minus 1. And when I do this one here, they have the same base. Using the law of indices, I can collect 1, therefore it becomes what? T power minus 2, then LT power minus 2. This is the dimension for acceleration. This is the dimension for acceleration. Please don't forget, I told you that acceleration is a vector quantity, it's not scalar, and the unit for measuring it is meter per second square. And we also said the time rate of change of velocity, that's for acceleration, and the time rate of change of velocity, where the change of velocity of any body or any object. Okay, I think at this point I will end this class. My next class is going to be what? Equation of motion. We are going to look at the equation of motion. That is going to be my next class. Thank you for staying with us on this class. Thank you very much. God bless you.